So we're going to take a look at this problem. 5x plus 31 equals 3 plus 3x. So, Valerie, this kind of goes back to what you were saying in the last problem, in the last video. Why would I move one term as opposed to another? In the last one, it was because there was only one variable term, so I wanted to get him by himself. Here, I've got two variable terms. These guys are both variable terms, and these guys are my constant terms, right? But what we have to make sure that we do is that we have to separate these. We need to make sure that we have variable terms on one side, and we need to get constant terms on the other side. So that's what we have to do. Now, it's up to you how you want to do this. A lot of students, Karen, want to move the variables to the left, right? That's where you want them to be. So here's this guy. How can I move this guy to the left side? I'm going to subtract 3x, right? So if I subtract 3x on the right side, that changes the problem unless I also do what? Subtract 3x on the other side. Now, if I subtract 3x, where should I put that if I'm doing this column format? Underneath the like term to it, right? What's 3x minus 3x? So that means I have effectively moved it to the other side. Let's combine like terms now. So what do I have here? It's a positive 2x. This is still a positive 31. And this equals 3. Now, I don't know if you guys recognize what's going on here. But in that one step, I've now made this problem look like every other problem that was on the last video, right? It usually takes one step to get it to look like something we've already done, and then we just keep moving with that. So, looking back at the problems that we had just finished, how do I go about getting the variable by itself now? I moved the variables to the left. I need to move the 31 to the right. Put them on opposite sides. We accomplished that by subtracting 31. Right? So now, that gives me 0. I have 2x equals how much? Ooh, if you're 31 years old now, how old were you 3 years ago? 28. And of course we keep the negative here, right? Because the negative number is larger in terms of the absolute value. Look at this guy. Now he's like an even simpler problem where we just had to get rid of the coefficient. How do I get rid of this coefficient of 2? I divide both sides by 2, which gives me x equals how much? Ooh, what's half of 2? There you go. It's negative 14. Half of 2 is 1. Half of 8 is 4. This is not the only way to do the problem. In fact, we're going to work it again, because I want you to see that you have options. Some students like to move the terms in a different way. So maybe you're the kind of person that likes to, go against the flow. You know what? I'm going to move my variables to the right. That's what I like to do. So you subtract 5x to move it to the right side, but you have to do it on both sides of the equation. Do you all agree? 28 divided by 2? See, now you're making me second guess myself. Well, no, I know this. So the x's on the left reduce, and I have a positive 31. Do I need to write the plus here anymore? No, I'm okay with that. So this equals 3, what? What is this stuff? 3x minus 5x is a minus 2x. Now, how do I get the variable term by itself? Right, this is where I have to subtract the 3 to the left side. That gives me 0 on the right with those 3's. What's 31 minus 3? 28 equals, do I need to put this sign here? Yes. I didn't need to put it for the 31, but I could have, right? But if I don't put it here for the 2x, and I just have this, what is that understood to be? Positive. But you see that the minus is connected to that, so it's a negative 2x. And how do I finish getting x by itself in this case? Divide by what?
Negative 2.
No, you only divide by the coefficient. Just divide by negative 2. You divide by x, I'm going to put a bigger x on top of that. What's 28 divided by negative 2? Negative 14 equals x. Isn't that the same thing I had before? So either way you do this, it doesn't matter. But you've got to watch out for your sign.